Alright, Algebra, you have a short video for the weekend. It's over like terms. You should already know what these are, but we're going to go over them anyway, just one more time. Just kind of have a review before we start class Monday. Alright, a like term are terms that contain the same variables to the same power. They have to have the same variable and the same power. Now, a term is anything added or subtracted. Anything added or subtracted. So, in other words, 2 plus 3, these are terms. The 2 and 3 are terms because they've been added. X plus 3, these are terms. And 2x squared plus 3x minus 3, these are terms. Now, here's the deal. It's not the 2 that's a term, it's the whole thing that's a term. This whole thing is a term. This whole thing is a term. Anything added or subtracted. So when we're looking for like terms, we're looking for that whole thing to be the same. So let's try this. 3x plus x. Well, this is what we're looking for. Do they have the same variable? Yeah. Are they to the same power? Yeah, they have an understood one power here. So they're the same variable to the same power, so now we can add them. So 3x plus 1x is like saying 3 apples plus 1 apple is 4 apples, or 4 x's. And that's it. Now, a lot of people get confused. This is a 1x, like 1 times x. But you don't have to put a 1x. You can just put x. In fact, I prefer it that way. Okay, here's another one. 4x squared minus 2x squared. Do they have the same variable? Yes. Do they have the same power? Yes. So we can add and subtract them. What's 4 minus 2? 4 minus 2 is 2x squared. That's all there is to it. Now here's a little bit more difficult one. You should know the distributive property by now. When you have a 3 times a parentheses, you're going to distribute the 3. So 3 times x, and then 3 times 2. So you get 3x, 3 times x, and 3 times 2 is 6. And then you write the rest, 4 plus 4. Now, we're looking for like terms. Well, here's a variable. Is there any other variables in here? No. So it doesn't have a like term. If it doesn't have a like term, you just rewrite it, 3x. Now 6 and 4 both do not have variables. So they're actually considered like terms because they're just numbers. They're just whole numbers. So 6 plus 4 is 10. We can collect those. And that's it. Now, 3x squared, oh, that's not supposed to be there. Let me give you another example. What if we had 3xy minus 3x plus 2? What does that equal? Well, let's look for like terms. Let's look for the x. Here's an x. This one does not. So it's by itself. So really, we can take it and move it down here automatically. Now, here's the other thing. This whole term has to be the same as this whole term. So where do you see that's different? This one has a y, and this one doesn't. So these are not considered like terms. So what do we do with things that are not like terms? We move them. Just move them straight down. If I can get it to move. There we go. Move straight down. And that's what we have. Now, you notice it really didn't do anything. All we have is 3xy minus 3x squared plus 2. Well, right now, that's all we can do. Because we don't know what x is, we don't know what y is, so all we can do is simplify it by collecting like terms. So this is the answer. You're done. Let me show you another example. Let's see, what if I had 2x times 4x plus 3. Now this might be a little bit too much, but we're going to go over it anyway. I'm just going to show you an example that you'll see later on. If you do 2x times 4x, you do the numbers multiplied to each other, and then x is multiplied to each other. We kind of went over this last year, but not much. Now we do 2x times 3, and you get 6x. And then the plus 2 just goes right here. Now we collect like terms. There's not any like terms, so we just leave it. We're done. And that's pretty much all the lesson is. So I can't wait to see y'all Monday. I hope y'all have a great weekend.